Welcome to the Unit 3 Section 6 video on the quadratic formula. So far we have learned several methods for solving quadratic equations, including graphing, factoring, using square roots, and completing the square. All of these methods are nice to use, except most of them have drawbacks because in certain situations we can't use it. Like the issue with graphing is if we're doing it by hand, it only works when we have the graph come out to nice round numbers, when we have the solutions be nice round numbers, because if we end up with solutions between two integers, we're not quite sure what that number is. We can't give you an exact solution. With factoring, well, we're not quite sure what the solution is, or if we can even get a solution if we can't factor it. So all of these methods are nice to use when they work, but there is one method that can always be used, and another method to use is the quadratic formula. And the nice thing about the quadratic formula is that it is useful and can get you an exact solution every single time when you are working with a quadratic equation that is in standard form. Okay, so before we get into using the quadratic formula, because using it is relatively simple, it's just a matter of plugging in values, and we'll do quite a number of examples of that just to kind of get a little bit of practice on it. But aside from that, let's talk about the derivation of the quadratic formula. Okay, so you start off with the quadratic equation in standard form, ax squared plus bx plus c equals 0. So to get the quadratic formula out of this, the first thing we're going to do is we're going to actually implement some of the concepts that we've been talking about in the last few sections. So first thing we want to do is we want to divide both sides by a. So remember in the last section, we don't want anything leading in front of that x squared. So in order to avoid that, we're going to divide everything by a. Next, we're going to move that c over a term to the other side, because we want our x's on one side and we want things that are constant on the other, which c over a is just a constant. So that pulls us here. We're at x squared plus b over ax equals negative c over a. Just remember, b over a and negative c over a, they're just numbers, okay? Those are just numbers. Our only variables here are x, okay? A, b, and c are just placeholders for some numbers, okay? Now that we have it in this form, and we've got our x's on one side and our constants on the other, now we're going to complete the square. Remember the method for completing the square. We're going to take what's in front of x, divide it by 2, and square it. So when you divide b over a by 2, you get b over 2a. And then when you square it, you get b over 2a quantity squared. So we're going to add that to both sides. So now that we've completed the square and we've added that to both sides, now we can factor the left-hand side, because that is a perfect square trinomial. The square root of x squared is x. The square root of b over 2a quantity squared is just b over 2a. And when you multiply b over 2a times 2, you get b over a, which is that middle term. So that is a perfect square trinomial. So we can factor it as such. Okay? So when you factor it as such, you get x plus b over 2a, so the square root of the first, which is x, square root of the second, which is b over 2a, the sign of the middle term is positive, and we're going to square it. On the right-hand side, since we were working on the left-hand side doing that, let's factor and simplify. Okay? So we factored the left-hand side, we're simplifying the right-hand side. So all we did was we moved this b over 2a quantity squared term in front. So we lead with a positive. And we went ahead and squared everything. So b squared is b squared, 2 squared is 4, and then a squared is a squared. And then we have minus c over a on the end. Now at this point, let's just work on the right-hand side a little bit more. So we're going to leave the left-hand side as it is these next couple of steps. We're just going to work the right-hand side. Well, if we want to combine these two fractions, what we need to do is find a common denominator. The first term is fine because we've got an a in here already. We have an a in the second term. So let's multiply the top and the bottom of the second term by 4a. That way it gives us 4a squared on the bottom. And if we multiply the top by 4a, it gives us 4ac. So you're starting to see parts of the quadratic formula emerging here. If you already know what the quadratic formula looks like, you're starting to see some things emerge here. So now that we have a common denominator for both of those fractions, we can combine it into b squared minus 4ac all over 4a squared. So you notice we're not at the 2a part yet. If you know the quadratic formula, you're expecting a 2a to be at the bottom. We're going to get there in this next step, because now we are ready to take the square root of both sides. So if we take the square root of the left-hand side, we're just left with what's inside the square root, or what's left within the squared. If we take the square root of the right-hand side, then we're just going to have plus or minus the square root of everything on the top, b squared minus 4ac. But we can take the square root of the bottom. The square root of 4 is 2, square root of a squared is a. So that's where 2a comes along. Okay? Now all that's left is to subtract b over 2a from each side, so that we have negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. But you notice that both of these have a common denominator. So since they have a common denominator, we can go ahead and combine it. And so we simplify, and we end up with x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that is our quadratic formula. We just took standard form. We took a quadratic equation in standard form, and we solved it without any numbers in place, just variables, so that we can come up with a formula that we can plug our a, b, and c into for any quadratic equation and be able to get a value for x. And this works every single time. So the result was the quadratic formula. The solutions of a quadratic equation of the form ax squared plus bx plus c equals 0 with a not equaling 0 are given by this formula. Let's talk about why a cannot be 0. There's two reasons. One, if you look at the quadratic formula, you'll notice that if a is 0, then we end up with something divided by 0, and you cannot divide by 0. That's undefined. That's true, but think about the quadratic equation. Are you ever going to have a situation where you're solving a quadratic equation where a is 0? The answer to that is no, because if a is 0, your x squared term goes away, as we talked about in the last section, and we're left with bx plus c. And therefore, we don't have a quadratic equation anymore. We now have a linear equation. And if we have a linear equation, we don't need to use the quadratic formula because it's not a quadratic equation. So the nice thing about this is it's nice because we are never going to end up with a quadratic equation that we're going to be solving for where a would be 0. So it all works out very nice and neat. So now that we know the quadratic formula, let's do some examples where we use it, okay? So this is going to be a section where you can kind of pick and choose. I'm going to run through 8 of these, okay? Some of these we did in class, some of these we did not do in class. So some of these are going to be additional examples if you need them, and if you wanted to fill out the rest of your notes, they're here for you. So let's solve these. And I've gone ahead and provided the quadratic formula as a start for each one of these problems. So let's start with A. If we want to solve this, all we have to do is substitute in our b, which is 3 here, plus or minus the square root of b, which is still 3, squared, minus 4, a, which is 4, c, which is negative 85, over 2a. And a again is 4. All right, that's a lot to simplify. I suggest that you start with what's under the square root. So we went ahead and did the minus 3 here. So we'll kind of take each 3 of these. We do the minus 3 on the front. We're going to do what's under the square root, and then we'll go ahead and multiply what's on the bottom in this first step. So what's in the square root? If you put that into your calculator and put it in carefully using parentheses where needed, you end up with 1369 under the square root, and then 8 on the bottom in the denominator. Well, the square root is 1369. I always use the calculator to check to see if that comes out even, because if it comes out even, we're in pretty good shape. And that one does indeed come out even. The square root of 1369 is 37. And then we're still over 8. So at this point, we can actually get numerical answers. So I'll let you do the math on that. But what we end up getting is p equals either negative 5 or 17 over 4. Because remember, you're going to have one answer for plus, one answer for minus. All right, well, moving on to example B here. We're going to plug in our things. So we got negative 5, so the opposite of negative 5 is what's going to end up going in here. Plus or minus the square root of negative 5 squared minus 4 times 3 times negative 10 all over 2a, where a again is 3. So we simplify that negative 5, that's going to be positive 5. What's under the square root ends up becoming the square root of 145. And the bottom is 6. And as it turns out, you cannot simplify the square root of 145. So if you want to just leave it as that, r equals 5 plus or minus the square root of 145 divided by 6, then you are more than welcome to. All right, example C. We're going to plug in our values, just like we did before. So these are not the most exciting examples because a lot of it is just plugging it into the formula. And I would suggest working with the formula as a starting. So if you're doing exercises, I would suggest that you start with writing the formula as is every single time. That will help you remember the formula. Okay, so now that everything's plugged in, we end up with 4 on the front. We end up with the square root of negative 200, and then 18 on the bottom. Now here we can do some simplification on what we have under the square root here. So we've got 4 plus or minus. We know that we can simplify 200 into 102, so 100 times 2, and then we've got our negative 1 out there, square root of negative 1, and then we have 18. And then this gets us to 4 plus or minus 10i square root of 2 over 18. And so we have x equals, so at this point we can reduce everything. 4 can be divided by 2, 10 can be divided by 2, 18 can be divided by 2. So we have 2 plus or minus 5i square root of 2 over 9. All right. For example D, you'll notice that we don't have something equal to 0. So we're going to have to get that step in first. So we have 10n squared minus 12n plus 5 equals 0. We had to subtract 12n from each side, so we got it into standard form. Now that we have it in the standard form, we can do the quadratic formula as we did before. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we have 12 plus or minus the square root of, once you do all of that in your calculator, you get negative 56 over 20. And then from here, we're going to simplify the square root of negative 56. And that is going to end up being 12 plus or minus the square root of 4 times 14 times the square root of negative 1 over 20. So we end up with 12 plus or minus 2i square root of 14 over 20. And so we end up finally with, if we reduce everything, 6 plus or minus I square root of 14 over 10. All right, let's move on to this next example. Again, we are going to have to get everything on one side with 0 on the other, so we have it in standard form. So that gives us 9x squared plus 6x minus 17 equals 0. And then from here, we're just plugging into the quadratic formula. So we have x equals the opposite of b, which is, in this case, 6, plus or minus the square root of 6 squared minus 4. A is 9, c is negative 17, all over 2a, which is 2 times 9. So we have x equals negative 6 plus or minus, when you do the square root, you end up with 648 over 18. Now I'm going to go ahead and let you simplify that square root. When you simplify that square root, you're going to end up getting it simplified down to, because we've done plenty of practice on simplifying square roots, it ends up being 18 square root of 2. And then when we simplify that down, you can actually break it up if you'd want to, because we're going to end up with negative 1/3, because negative 6 over 18 is negative 1/3, plus or minus the square root of 2. For f, we got to move everything to one side, so we got 3n squared plus 4n minus 95 equals 0. And so here we have n equals the opposite of 4 plus or minus the square root of, let me try to make that a little bit nicer, the square root of b squared, which is 4 squared, minus 4ac, which is 4 times 3 times negative 95, all over 2a. So 2 and then a is 3. So we've got negative 4 plus or minus the square root of, when you do that math underneath the square root, you end up with 1156. That's going to be over 6. And as it turns out, square root of 1156 actually comes out even. It's a perfect square. So 1156 is the square of 34. So now that we have this, you can actually do the math and get it into two specific answers. And those answers are 5 and negative 19/3. All right, let's do 2 more examples and then we'll move on to the last topic of this section. So for G here, we have to get everything on the one side. So we are going to subtract the 4x squared from the 5x squared, so that gives us x squared. And then negative 18x plus 8x gives us minus 10x. And then we have plus 25 here equals 0. Now you may recognize this as a perfect square, and it is, but let's use the quadratic formula. So we have x equals the opposite of b, so the opposite of negative 10, plus or minus the square root of negative 10 squared, minus 4, a is 1, c is 25, over 2 times a, which is 1. X equals 10 plus or minus. So when you do everything under the square root, you end up with the square root of 0. So if you end up with the square root of 0, everything behind the plus or minus goes away, and you're just left with 10 over 2. So x equals 5. So we only have one solution. Does that make sense? Well, yes it does, because when we have a perfect square, we would expect to have one answer. And so keep in mind here that when we end up with the square root of 0 in the quadratic formula, that's always going to give us one answer, because 10 plus 0 is 10, 10 minus 0 is 10. So you end up with two of the same answer, and if you have two of the same answer, you really only have one answer. So keep that in mind here. We'll do one more example here, but keep G in mind for when we move on to the next section. All right, let's do one final example. So we need to move everything to one side, and when we do, we end up with 8x squared plus 9 equals 0. And when we do this, we're going to end up with x equals the opposite of b. Well, what's b here? Well, we don't have a b term. There's no x term. So could we solve this in another way? Could we solve this by taking square roots? Yes, we could, but let's see what the quadratic formula gives us. So b here is 0, plus or minus the square root of 0 squared minus 4a, which is 8, and then c, which is 9, all over 2a. So a is 8 here. All right, well, this front term goes away, so we're just going to be left with plus or minus the square root of, when you do the calculation under the square root, you end up with the square root of negative 288 divided by 16. Well, we know that's going to give us an imaginary solution because we have a negative under that square root. So I'll let you simplify that square root, and when you do, you end up with 12i square root of 2 over 16, which we can reduce that down into plus or minus 6i square root of 2 over 8. So that would be our answer. We have an imaginary solution. In fact, we have two imaginary solutions. So notice under the square root, if we end up with a negative under the square root, then we end up with imaginary solutions. When we had 0 under the square root in G here, we end up with one solution. And then in the other examples, when we had a positive number under the square root, we ended up with two real solutions. So what's under the square root does give us some information. So as I just mentioned, what's under the square root gives you some information about how many solutions you're going to have. And we saw that with some of the examples that we just did. So if a quadratic equation is in standard form, the discriminant of a quadratic equation is what's under the square root, the b squared minus 4ac. That part under the radical sign can tell you how many solutions a quadratic equation will have. So here is a list of what it means. If it's positive, you have two real solutions. If what's under the square root is 0, you have one real solution. And if it's negative, you have two imaginary solutions. So let's do a few examples of that to wrap up this section. So let's find the discriminant of each quadratic equation, then state the number and type of solutions. So first thing you need to do is, like we did with the quadratic equation, get all of your stuff on one side. So that's what we do here. We moved negative 8k to the other side by adding it, and now we can parse out what a, b, and c are. So we have b squared minus 4ac. Well, b here is 8. A is negative 6, and we don't have a c term, so it's 0. So that gives us 64, because 8 squared is 64. So since we have a positive number, we have two real solutions. For b, we're going to move everything to one side by adding 10n. Now we can take our discriminant, which is b squared minus 4ac, plug in our b, which is 10 squared minus 4a, which is 7, c, which is 7. And when you do that math, you end up finding it's negative 96. So since it's negative, we have two imaginary solutions. On the C here, example C, we have negative 2k squared equals negative 9k. We got to move that 9k over to the other side. So we got negative 2k squared plus 9k equals 0. And we are going to put all of that into our discriminant. So we've got 9 squared, because 9 is b. A is negative 2, and again we find that c is 0 because there's no c term here. 9 squared is 81. So we find here that we have two real solutions. For D, we're going to move our 8k over to the other side. So we've got negative 4k squared minus 8k minus 4 equals 0. So let's put in to b squared minus 4ac what our a, b, and c are. So we end up with negative 8 squared minus 4 times negative 4 times negative 4. Well, that's going to give us 64 minus 64, which is 0. So since the discriminant is 0, you have one real solution. So this is where you have to be careful. Remember, if the discriminant is 0, that just means what's under the square root is 0, which means what follows the plus or minus is 0. So that just takes our solutions down to 1 instead of it being 2. Don't look at 0 saying there's no solutions. There's going to be no case where we don't have any solutions. We're either going to have two real solutions, one real solution, or two imaginary solutions. All right, let's go on to the next example. We have negative 7x squared minus 2x. We got to add the 3 to the negative 11, which gives us minus 8 equals 0. And then we just go to our discriminant. B squared minus 4ac equals, our b squared is negative 2 squared. Our 4ac is 4 times negative 7 times negative 8. And if you do that math, you end up with negative 220. So since it's negative, we have two imaginary solutions. And then finally, the last example, we have negative p squared plus 4p. We're going to add, or we're going to subtract 3 from each side, so we end up with minus 4 equals 0. And now we're going to put in our b squared minus 4ac. So that's going to be 4 squared minus 4 times negative 1 times negative 4. And all of that together gives you 0, which means we have one real solution. So after you evaluate what's under the square root in the quadratic formula, you can very quickly determine how many solutions you're going to have and what type of solution you're going to have, if it's real or imaginary. Okay, so that wraps up this section of notes for Unit 3, this Section 6 notes. We're going to move on to talking a little bit about all of the different methods that you have learned so far in the next section, and then we'll also talk about applications of quadratic equations and solving quadratic equations by doing a few real-world problems.